CR. This is our critical load. What topics will be covered? Okay, so Andy is asking what topics will be covered. Let's go back to the course outline. So February the 6th will be a term test. So the topics will be tested. We will be week 1, week 2, week 3, week 4. Okay. Test 2 will be tested on topics from week 5, week 6, week 7, week 8. Okay. And final exam, the topics will be tested will be week 9, week 10, week 11, week 12, and week 13. Okay, so these are the topics that we're going to test you on. Okay. Now, Andy, no, Raymond, is that okay? Okay, so there we go. Right. So we PCR is our critical load, and this can be in Newton or it can be pound force. Then E, like before, it is our Young's modulus. And this can be in Pascal or pounds per square inch. And then we have I, which is the second moment of area. It can be in meter to the power 4 or inches to the power 4. And L is the length of the structure. So this will be in meters and for inches. And for the first time that you have done like 2 P04, okay, this is the first time that what is unique about this formula is for the first time we have pi, okay, in a formula, right? You don't usually see pi at all, but for this case in buckling, we happen to have pi, and later on I will explain to you why after we derive this set of formulas. Then you see the why we have pi. So buckling only occurs when structures are under compression, axial loading. Okay. So what do I mean by that? Okay, what do I mean by that? So for simplicity's sake, we draw a simple structure. Okay, so this is the structure that we have. And then I'm going to sketch a green line. And this green line happens to be the centroid. Okay, this green line, it happens to be the centroid. So buckling will only occur if the load is acting in compression, like what you see over here. Okay. And for this case, P, as you can see, P is acting along the centroid. Okay. And when it's acting along its centroid, okay, this is classified as centric loading or centric buckling. Okay. Okay, centric buckling. And the formula to apply, as you can see before, is pretty straightforward. Is stress force critical pi squared E I over L squared. Okay. Now the next one is also buckling. Okay, and I'll show you the next structure. So the structure have the same thickness. Okay. And then we have our centroid. Same thing. This is still our centroid. Okay. Now the structure will also buckle if the load is not applied on the centroid. Okay. So if I were to, which I did forget, if we were to draw our transformation, this is X and this is Y, right? So you can see now, okay, that P, for this case, P is acting parallel to the centroid with an offset okay, with an offset distance E. Okay, so the E is basically from here to here. Okay, so when this is the case, this is classified as eccentric buckling. So they are not the same. Okay, one is applied exactly on the centroid, okay, along. The other one is acting parallel, but with an offset distance E. Okay. So for this case, the formula is slightly different. So I'll just write down the formula, which again, we'll go into detail later on. So you have maximum stress now is equal to P over A, okay, bracket 1 plus by EC over R squared. Oh, hold on. Second, okay, pi over 2 square root of PCR or square root of P over PCR bracket. Okay. So the formula is not exact, it's not the same. Okay, and later on we will derive y. Okay, we will derive y. Why they are different. Okay. Any questions from anyone so far? Are we okay? Okay. So you can see on the left hand side is centric buckling. On the right hand side is eccentric buckling. Okay. Right. So in if we were to look on the next thing that I want to go into detail is deformation pattern. Of buckling. When both ends are pinned. Okay, when both ends are pinned. So before we go any further, okay, so buckling will occur, okay, will occur when structure is under compression loading. Okay, it's under compression loading. So what this means, if we have a structure, okay, I'm drawing a simple structure for now. As you can see before. And this is our centroid. Okay. So when it's under compression, okay, this is where buckling will occur. So buckling will occur when it reaches the critical load. And if you have a structure, so you can see that for this case, we have it in the load of pushing towards the structure is what we call is under compression. And if we have a structure that looks like this, and then you have a load. Okay. Now the load is pulling in tension, is pulling away from the structure. This is what we call tensile. Okay. So when that is the case, buckling, oops, will not occur. So when you have structure that is under tensile loading, okay, you no need to carry out buckling analysis. Okay, you don't need to deal with buckling at all if you see tensile. So just I'm going to pick an example. If there's one, is there any one down here that I can pick? No, I'm going to get a diagram from a different book and show you guys. Okay, so if we have a, let's see. I'm looking for a simple structure. Yeah, if not, I will just sketch one. Okay, I don't think I can quickly find one to show all of you on. Yeah. Okay, I think we can use a good example over here. Probably you have seen this before when you guys were taking 2P. Okay. So let's look at this